Hello everyone, welcome to my channel Science Quickly. In today's video, we are going to talk about motion in a straight line. In this video, we will cover what is a scalar quantity and what is a vector quantity, and we'll see what is a body at rest and a body in motion. So let's begin with scalar quantity. Scalar quantities are the physical quantities which are expressed only by their magnitude. For example, if we say that the mass of a body is 5 kg, okay, when we say the mass of a body is 5 kg, it is a complete meaning and we have complete information about the mass. That is known as a scalar quantity. So in a scalar quantity, we have two parameters: unit in which the quantity is measured and the numerical value of the measured quantity. This is the unit in which the quantity is measured, and this is the numerical value. So for a scalar quantity, we need two things: numerical value and the unit. Some examples of scalar quantity are mass. Again, mass SI unit is kg. Other example is length. The SI unit is meters. Time, SI unit is seconds. Okay, these are some examples of scalar quantity. Now a scalar quantity is just written in short by a small symbol. Like for mass, we have a symbol small m. For length, we will use small l. For time, we will use small t. So these are the symbols for writing a scalar quantity. Now let's see what is a vector quantity. Okay, so let's see what is a vector quantity. I'm writing in short over here what is a vector quantity. These physical quantities require the magnitude as well as the direction to express them. Then only their meaning is complete. Again, if you see in a scalar quantity, we need the magnitude and the unit. But in a vector quantity, we need magnitude and we need the unit and we need the direction. So we need first of all magnitude, we need the units, and we need the direction. Let's take an example. Displacement is a vector quantity. The symbol for displacement is, we write an S with an arrow on it if it is a vector quantity, or we write a bold S. Of course, I cannot write bold over here, but again, we'll normally just write an S over here because we don't care about the bold when we are writing in our notebooks and all that. So let's see, when we say displacement is a vector quantity, when we measure displacement, if you say the displacement is 5 meters, now this means the displacement is positive 5 meters. Let's say a body starts from here, point A, and it goes all the way up to point B. This is the direction of the body going from A to B. We are going to call it as the positive direction. And the displacement is 5 meters. So this distance over here will be 5 meters from A to B. Now if I say displacement equals to minus 5m. Now again, this is a completely different story over here. This means the body is going from B to A in the opposite direction. And that is why we use a negative sign. So negative sign basically tells us that the direction has changed. Same thing happens with velocity. We can say velocity. Velocity is also a vector quantity. The symbol for velocity is small v with a arrow on top, velocity equals to 5 meters per second. This is positive 5 meters per second. If I say velocity equals to minus 5 meters per second, now in this case, the direction has become opposite. Remember, the magnitude is same, 5 and 5. The units are same, meters per second, meters per second. But the positive and negative sign tell us what is the direction of the velocity. So velocity is a vector quantity. The next part, what we're going to talk in this video is rest and motion. A body is said to be at rest if it does not change its position with respect to its immediate surrounding. Okay, so body is said to be at rest if it does not change its position according to its immediate surrounding. Like for example, we are sitting on a chair. Our immediate surrounding is our room. Now you can observe that the things in your room, like your bed, your chair, or the television, or the furniture, it does not move. So what we can say is that your body is at rest. On the other hand, if you are standing at a railway station, if you're standing at a railway station and if you see a train going by, let's say these are the tracks, and if you see a train going in this direction over here, what is happening is you are standing over here and the train is changing its position. The immediate surrounding is the railway station. The train is changing its position with respect to the railway station. So we say that the train is in motion. Now, technically speaking, even if you look at this chair, remember the earth is rotating on its own axis and it is revolving around the sun. So in a way, we can say that everything on this planet is in motion. But in physics, we do not consider that. We consider the immediate surrounding. What is surrounding the chair? The immediate surrounding of the chair is not changing its position. So we say that the chair is at rest. Similarly, if you see the train from a railway station, you will see that the train is changing its position with respect to the immediate surrounding, which is a railway station. So we say that the train is in motion. Now let's go to the next part, which is one-dimensional motion or rectilinear motion. Now that is all we are going to talk about in physics, because we are not going to study about the multi-dimensional motion in this chapter. Okay? So now let's see what is a one-dimensional motion. One-dimensional motion. When a body moves along a straight line path, its motion is said to be a one-dimensional motion. It is also called motion in a straight line or rectilinear motion. So if a body moves in a straight line, okay, if it moves in a straight line like this, let's say if the body is going from point A to point B, this is point A and it is going to point B in a straight line. This kind of a motion is known as a one-dimensional motion. It is also known as a linear motion, and it is also known as a rectilinear motion. If a body moves on a plane along a curved path, its motion is two-dimensional. And if it moves in space, its motion is three-dimensional. We shall only consider single dimension motion. That means we are only going to study about one dimensional motion. When a body is moving in a circular path like this, that means it is moving in two dimensions. When a body is moving in space, it is moving in three dimensions. We are not going to study about this. We are only going to study about one dimensional motion. Okay, that's all for this video. In the next video, we are going to talk about distance and displacement. We'll see what are the differences and all that. So please check out the next video to understand what is distance and displacement. Thank you.